All right, we want to find this derivative of this integral. So we want to do this two ways. We want to do it the kind of normal way, which is by evaluating the integral and then differentiating the results. So to evaluate this integral, 0 t to the 10th, fifth root I'm going to write as u to the 1/5 du. So my definition of define this antiderivative, I add 1 to the top, add 1 to the bottom. So I'm going to end up with u to the 6/5 over 6/5, because 5 over 5 would be the 1, or 5 over 6 u to the 6/5, evaluating it at 0 and t to the 10th. So that's my limits of integration that I'm going to plug in here. So I get 5, 6, my u is t to the 10th to the 6/5 minus 5, 6 times 0 to the 6/5. Of course, that just cancels. So I end up with 5, 6, t to the 10 times 6 is 60. 5 will go into 60 12 times. Or you could have said 5 goes into 10 2 times, and 6 times 2 is 12. Alright, so I integrated it, and now the instructions said, and then differentiating the results. So in other words, I find this derivative, 5, 6, t to the 12th. 5, 6 can come out front, bring the 12 down, subtract 1, so that's finding the derivative. Or this becomes 6 goes into 12 2 times, 10 t to the 11th. So that's the first part. The second part says that this whole fundamental theorem of calculus says that this derivative is equal to taking the derivative of this integral. And it will give me my original function back. So in other words, I'm going to differentiate the integral directly instead of doing it in steps like that on part A. That's an A. Okay, so on this integral. Well, so in other words, we want to differentiate this 0 t to the 10th, fifth root u du. But the problem is this upper limit needs to be just t. It needs to match my definition. And so I can do that. That's my magic in math, right? I can do anything I want. I can let y equal this integral, 0 t to the 10th, fifth root u du. So I just created a new interval that's going to be composed of this y now as a function of v, where v is going to be my t to the 10th. So where v equals t to the 10th. So now this looks just like my definition, and then away I can go. So to find dy dt, because I created this new function here, and v is a function, is t to the 10th, then this is going to be my chain rule. So my chain rule says to find this derivative, I find the derivative of y with respect to v times the derivative of v with respect to t. So that's my chain rule piece, because I have two functions here. I have this function and I have this function. So in other words, I need to take the derivative of this u v fifth root u du times, well, I know what dy or dv dt is. That would just simply be 10t to the ninth. That would be this derivative. So that piece I know, and I can just write it in. Well, now I've got to figure out, well, once again, I'm still stuck. I don't know what to do with that. Sure you do, because you understand from the fundamental theorem of calculus, if I take the derivative and integrate, I get my original function back. Original function. And so in other words, it's kind of like a, oh, that stuff just cancels out and I'm just left with my original function. But the only part you have to be careful is you still have to evaluate it with these limits. So in other words, let's just write this out. Dy dv equals this derivative, uv, let's write u to the 1/5 again, du. And so if I get my function back, I just get u to the 1/5. But I've put this in terms of v, so it's actually v to the 1/5 minus 0 to the 1/5, so that'd just be 0. So going back from up there, dy dt equals this derivative that we just found, v to the 1/5 times that derivative, 10t to the ninth. Well, we said that we let v equal t to the 10th. Remember, way back up there somewhere, so v equals t to the 10th. So t to the 10th to the 1/5 times 10t to the ninth. And thus we have 10t to the 5th times 10t to the ninth. Well, both of these have bases of t, so I need to get a common denominator in the fractions so I can add the fractions. So 10t to the 45 over 5, because 9 times 5 is 45, so all I did was get common denominator. Now I can add these to get, that's a multiplication, to get 10t to the 55 over 5. And of course I can reduce that to 10t to the 11th, and that's the ta-da, way back up here. Hello. Right there is what I got in part A. So you should get the same thing.